Okay, let me discuss with you the derivative of composite function. That means how to find out the derivative of composite function or the derivative of a function of a function. Suppose y is a function of u and u is a function of x. Then how to find out dy dx? Dy dx will be dy du into du dx. That means to differentiate first y with respect to u and then differentiate u with respect to x. And then multiply these two to give you the value of dy dx or the derivative of y with respect to x. In general, if x1 is a function of x2, x2 is a function of x3, xn is a function of x. So what is the derivative of x1 with respect to x? It will be the derivative of x1 first with respect to x2 into the derivative of x2 with respect to x3 and so on, into the last one, the derivative of xn with respect to x. Then multiply all this, then you'll get the derivative of x1 with respect to x. For example, now let us come to this problem. Y is equal to sine of log x, or I can express this y is equal to sine u, where u is equal to log x. So how to find out dy dx by that formula? That means this one, it will be dy du. What is dy du? That means differentiate y with respect to u. It will be dy du into du dx, and this is equal to, what is derivative of y with respect to u? It will be cos u into what is differentiation of u with respect to x? It will be 1 by x. So it will be cos u by x, and this is equal to cos of, what is u? It is log x divided by x. So this is an application of that derivative of a composite function. Now let me come to the rest of the problems. I'll send you through PDF and you can go through. If there is any doubt or any problem, then you can give a comment in that Google Classroom. Now the next one is the derivative of logarithmic differentiation. Since all these things have been done in class 12, so I'm just going to explain you the method and then just one problem on each of this method. Then the rest of the problem will be sent to you. Okay, the rest of the solved problems will be sent to you through PDF. So now logarithmic differentiation is this one. There are two types. That is, if y is a function of fx whose power is also a function of x. For example, y is fx to the power 5 of x. Then in this case, how to find out the derivative of this function? What you need to do is taking log on both sides. So you'll get log y is equal to log of fx to the power 5x. But we know these properties of logarithm. Log of m to the power n is same as n log m. Then in that case, we'll get log y is equal to 5x log f of x. And then differentiate this one with respect to x. The differentiation of log y with respect to x will be 1 by y dy dx. And this one, you apply the product rule of differentiation. So you'll get 5 prime of x in 2. That means differentiate this one with respect to x, taking this as a constant. Plus next take this as a constant and differentiate log of fx. And we know the differentiation of log fx will be 1 by fx into the derivative of fx. So this will be the method or the rule to differentiate a function of the form y is equal to fx to the power 5 of x. And type 2 of this one is if y is a product of many functions, say f1x into f2x dash fnx. Then in this case also you take log on both sides. So log y will be log of f1x, f2x into fnx. But what is log of mn? It is log m plus log n. So here, by applying this property of logarithm, it will become log f1x plus log f2x plus log fnx. Then differentiate with respect to x, you'll get differentiation of this one will be 1 by y into the derivative of y with respect to x. And this is equal to derivative of log of this one will be 1 by f1x into the differentiation of this plus dash dash plus 1 by fnx into ddx of fnx. So it will be 1 by f1x, f1 prime x plus dash dash plus 1 by fnx into fn prime x. Now let us come to this problem. Find y is equal to log x to the power sine x. So here you take log on both sides, you get log y is equal to log of log x to the power sine x. And this will be sine x log of log x. Again, by applying the rule of this one, log of m to the power n is n log m. So now here, this is equal to sine x log of log x. So what is dy dx? You differentiate this one, you will get 1 by y dy dx is equal to, now this one is a product of two functions. So sine x it will be sine x into the derivative of ddx of log x plus log x into ddx of sine x. And this one will give you sine x into derivative of log x will be 1 by log x into the derivative of log x, it is 1 by x, plus log x into the derivative of sine x is cos x. So finally this one comes out to be sine x by x log x plus cos x log x. So this is the method of differentiating a function y is equal to a function of x to the power of a function of x. Now let me come to that type 2. Find dy dx if y is equal to this one. So here taking log on both sides, you'll get log y is equal to log of 1 plus x into 1 plus 2x into 2 plus 3x. By properties of logarithm, it will be log of 1 plus x plus log of 1 plus 2x plus log of 2 plus 3x. Now differentiate this one with respect to y. So you'll get 1 by y dy dx on the left hand side, and this is called differentiation of log x will be 1 by 1 plus x into the derivative of this one, it will be 1 plus differentiation of this one will be 1 by 1 plus 2x into the derivative of this one. 1 will be 0, differentiation of 2x will be 2, so 2 will come out from there, and the last one is 1 by 2 plus 3x into the derivative of this one, it will be 3 will come out from here. So it will be 1 by 1 plus x plus 2 by 1 plus 2x plus 3 by 2 plus 3x. So this is the derivative of function of the form y is equal to 1 plus x, 1 plus 2x, 2 plus 3x. Now let me come to this next one, derivative of an implicit function. In many cases, it may not be convenient or it may be impossible for us to express y in terms of x alone or explicitly express y in terms of x. So in this case, what we need to do is we differentiate each term, and then by considering y to be an unknown function of x, and then after that take all the multiples of dy dx and then find out what will be dy dx from that equation. So for example, for the case of implicit function, so you can consider this example, x cube plus x cos y plus y cube plus y cube is equal to 0. So let us find out what will be the derivative of this one. So differentiating this one with respect to x, you will get what will be differentiation of x cubed will be 3x squared plus, here it is a product function, so differentiate first, it will be 1 into cos y plus x into differentiation of cos y is minus sin y into dy dx plus y cubed, it will be 3y squared dy dx is equal to 0. Then after that, simplify it, you'll get 3x squared plus cos y minus x sin y dy dx plus 3y squared dy dx equal to 0. Transfer this all multiples of dy dx to that side, then you'll get 3x squared plus cos y is equal to x sin y minus 3y squared into dy dx. So you'll get dy dx now is equal to 3x squared plus cos y divided by this term x sin y minus 3y square. So this is the method of differentiating an implicit function of y. Now the last one is this one, the parametric function. That means if x is a function of t and y is also a function of t, then in that case how to find out dy dx? So dy dx will be given by the formula dy dt divided by dx dt. So you have to remember this, this rule of finding the derivative of parametric function. So now for example, if y is equal to at square minus twice at and x is equal to t cubed, then how to find out dy dt? So from this is 1, this is 2. So find out what is dy dt from equation 1. It will be a differentiation of t square will be twice t minus twice a. And from equation 2, what is dx dt? It is 3t square. Therefore, dy dx now is equal to dy dt divided by dx dt. And what is dy dt? It is this one, 2a is common, 1 t minus 1 divided by 3t square. So this will be the derivative of y with respect to x, when x and y are functions of t. Hope it is clear now regarding this rule of differentiation for a parametric function, for logarithmic function, for an implicit function, and also for the composite function. And the rest of the problem will be sent through PDF. You go through them. I hope it will be clear now how to find the derivative of these types of function.